Alright, today we are going to be doing an Empirical Formula Lab. Alright, and in this lab you're going to have a crucible. Just write this applies over here. Ring stand. A Bunsen burner. Known amount of mg and an unknown amount of oxygen from environment. You're going to have a balance, and you're probably going to want some tongs so you don't burn your hands. Alright, so in this lab you're going to have a crucible, and the first thing you're going to do is you're going to weigh the crucible. So we'll say that the mass of crucible is equal to 10 grams. Next, you're going to take the crucible with a amount of mg in it. Say that's our mg there. And we'll say that the mass of crucible with mg is equal to 16 grams. And with some math there, we could take the 16 grams minus the 10 grams, and that equals 6 grams of mg. We just got rid of the mass of the crucible there. So once you have your known mass of mg, you can take your ring stand, so we'll say that's right here. There's your ring stand, and you'll have the crucible sitting in the ring stand like that with the lid slightly cracked and the mg inside. And what's going to happen here is oxygen floating around in the air is going to go into the crucible and bind with the mg in there to form a new compound of some mg and some O. So you're going to need their Bunsen burner here, and you'll have that burn, and you're going to burn and cool and then mass with your balance, and then burn again. You're going to do that 3 times to make sure that the reaction is complete. So after you've done that 3 times, you're going to take you're going to want to weigh the crucible a final time, and we'll say that final mass of crucible plus contents is equal to, we'll say, 20 grams. And so you're going to do some math again there, and you're going to take the 20 grams minus the 16 grams, which is what the crucible weighed before the oxygen came in and bonded to the mg. So we'll do the subtraction there, and we'll get 4 grams of oxygen. Alright, now that you know your amounts of mg and oxygen, you'll take the 6 grams of mg up here and the 4 grams of oxygen, and you're going to divide those by the masses on the periodic table. So for mg, that's 24.3 grams per mole, and for oxygen it's 16 grams per mole. And when you do that, you'll get 0.25 moles mg, and then you'll get 0.25 moles oxygen. And you'll divide that by the smallest, and in this case they're both the same, so you divide both by 0.25, and you'll get 1 mole of Mg and 1 mole of oxygen. And this simply means that your formula for your substance in the crucible is MgO. So that's how you do that. And now we'll do a practice problem here for you to do on your own. So we'll say that we have 18 grams of Mg and 12 grams of O. And I'll just let you guys try to solve that. So at this point in the video, you're going to want to pause it, and I will resume shortly here for you to do the problem. Alright, hopefully you guys have figured it out now. So what you're going to want to do is you're going to take the Mg divided by the mass on the periodic table, which is 24.3 grams per mole as before, and then oxygen, which is 16 grams per mole, and you're going to get 0.75 moles Mg and 0.75 moles oxygen. And then just like before, you're going to want to divide by the smallest. In this case, again, they're the same. They're not always going to be like that, but in this case they are. And so you will get 1 mole of Mg and 1 mole of oxygen. And again, your empirical formula will be MgO because you only have 1 mole of each left over. Alright, that is how you complete a Empirical Formula Lab. Thanks for watching.